In this video, we're going to take a look at three interesting projects. One of them is AI Coding Manager. Second one is going to be a Groq Voice Assistant, which actually takes your voice as instructions and writes emails and all sorts of things and can modify them. And the third one is a guided meditation app, which actually creates guided meditations with automatic pauses injected in between instructions. Quickly speaking, AI Team Manager allows O1 Mini to become the project manager and creates the specs for each file. Then we use Claude to generate one Claude agent for each file to generate these files in parallel. Each agent works independently without knowing what the other agent is doing. So therefore, the detail-oriented approach of O1 Mini is going to be important. We're going to take a look at that. The second one is going to be Groq Voice Assistant, which actually takes voice inputs. Let's actually take a look at a demo of it real quick. Write an email to my boss asking for a raise. Here we get the email super quick. We can modify it. My boss's name is Mike and my name is John. Here it changed the names appropriately. Please make this extra polite. Please make this extra polite. Here we go. You can actually select this sincerely and change this to kind regards. And here we get the kind regards. Please remove the sincerely. There we go. We just changed it to regards. And let's say we can select this paragraph. Please make this paragraph a little bit annoyed sounding. Yeah, see, it only modifies that paragraph. We can refresh this and please give me a list of vegetables. There we go. I can select the carrot, change this to apple, submit, and we are able to change it pinpoint. So this is very fast, uses Groq. This is available at my Patreon. The architect level link will be below. Thank you. And the third app is a guided meditation app, which can create guided meditations of all different types, Dzogchen, Transcendental, Vipassana, Love and Kindness, but you can modify it to your liking. It also uses structured output, so we'll take a look at that. So this should refresh our memories on that. Here is a guided meditation created on Dzogchen. I'll play this for a second so you can see the pauses here are injected automatically and programmatically.
Find a comfortable seated position, ensuring your back is straight and your body is relaxed. Gently close your eyes and bring your awareness to your breath, noticing.
Okay, I won't play the whole thing, but that pause was injected in it automatically through iDub. Okay, we'll review the code. This project files, all three of them, are available at my Patreon. You can download them from there by becoming a patron. The links will be in the description. But I built the AI Coding Manager live during a live stream for my patrons. I'm sorry, for my 1000X Masterclass. And a preview of live building of this will be available at the end of the video if you want to take a look at it. And you can if you become a patron, you'll have access to my entire 1000X Masterclass. Currently has 20 chapters. Okay, so let's begin by running the AI manager, see how it works, and I will review the code for each one. Okay, just as an example, let's copy this instruction to build a fully featured tower defense game. And let's run the AI manager. It's going to be initialized. Please describe the project you want to create. We're just going to paste this. Please build a fully featured tower defense game and Pygame. Don't use any external assets. And user input is received. Now it's generating the project plan based on user input. When it's done, we'll be able to see it in our files. This part of the code takes quite a while since O1 Mini takes quite a long time to write the specs. You can also try O1 preview for this phase of the task. Okay. Our project is completed. So surprisingly, it didn't use very many reasoning tokens. We are printing it right here, but it created a project plan and instructions for each file, quite a lot. We can review them here, and actually all the files were written very quickly because we are running the coder agents in parallel. But let's begin by taking a look at the project plan. Here is the plan instructions or the project plan. Here is the overview. It gives a structure to each file and then creates goals, interactions, and some other explanation in the general plan. But then each one of the files are actually outlined, which modules it requires, purpose, class definitions, and so that since each manager, each coder agent is going to work independently, it needs to know all this stuff. And then here are the code that is being written by each coder. There is a total of, let's see how many files. 11 files were written. So this is a multi-file project. And here are all the files that were written. And we have a auxiliary helper code here to count how many lines in each .py in this project. We can actually run this. This actually excludes the AI manager. Surprisingly, it wrote very 643 lines of code in all of these files. Actually, sometimes I've seen it write upwards of 1200. And we can try to run it. Unfortunately, this is more of a proof of concept. And it still makes errors because each agent is dealing with a separate file. But we can try to run it. And actually, yeah, see, so it just makes mistakes. I believe AI Manager needs a better instruction. So let's go over the code now. This is, like I said, is a POC to be able to create a project manager. I hope you'll get inspiration from this and actually improve it further. Like I said, the code files for this will be available in Patreon. We are using OpenAI and Anthropic. We're going to use async Anthropic client. Here's our project manager class. We are initializing our clients in the init method. And now here we have a method to generate project plan, which is going to take in the user input. I'm going to call O1 Mini. Here's our instructions. An AI project manager for a team of AI coders. Create a detailed plan for a multi-file project based on the following user input. And your response should include a detailed project plan enclosed in plan tags. This plan should outline overall structure, goals of the project. So each one of these parts can be improved. Like I said, O1 is very sensitive to instructions. Instructions for each file in the project enclosed in folder file name or just file name. It can actually create folders as well if it thinks it's needed. For each file, provide a complete and self-sufficient instructions that will allow a human developer to write the file independently without knowledge of other files in the project. Include details as such, the purpose, required imports and dependencies, functions or classes to be implemented, how this file interacts with other parts of the project, any specific algorithms and logics to be used, correct and complete import statements, detailed instructions on how to structure the file to facilitate imports from and to other files in the project. All variables, attributes, classes that need to be defined for each agent. Ensure that all necessary variables are defined and initialized correctly. You can read the rest of the instructions. So yeah, you can see where we're going with this. And when the message is received, we get the reasoning tokens and print them. And also, before continuing, I thought, well, this can be a head start for a large project, and you can actually use uh, Composer, Cursor Composer, to actually continue the project by adding all the files and fixing any issues. So consider that as well. Here we have a method to parse the response. This is just going to look at where the plan is and find all the instructions for individual files, looking at the tags, and then return a dictionary, which we will write to the file using the save project details. It's going to create a project plan directory. If it doesn't exist, it's going to write the project plan, and then it's going to write the instructions for each file separately here using this method. And then here is the coder team, generate file code. So in this particular case, we ran it. This is like a 12-person team, the manager being all one, and 11 coder agents that actually build each one of these files. It's going to take a project plan, file name, and file instructions. Here's our prompt that we're going to send to each Cloud agent. As an AI coder, you are tasked with implementing a specific file for a larger project. Here are the details. Then we pass the overall project plan. We pass the file name, specific instructions for this file, and then please generate the complete code for this file. Your response should be a full runnable code enclosed in file name tags. We pass the file name dynamically. Ensure that your implementation follows the given instructions, integrates well with the overall project. We use the latest Cloud Sonnet. Essentially, that's our method, which we're going to call it with async. That's why, um, yeah, it's an async method, as you can see. And extract code is to extract the code from whatever the file name returned was using the file name. And then here is the generate and save project, which is going to take in project files. So for each file and file name and instruction and project details dictionary, for each item, we're going to create a task list. And each task is going to call the generate file code with the project plan, file name, and instructions for that. Create a task list, and run it with async.gather and get the generated codes and loop over it and save it to file. This is pretty much it. And in the main function, we take in a user input, then generate a project plan, save project details, and generate and save project files. Yeah, I have a README for this too. If you do download it from Patreon. Like I said, if you become a paid Patreon supporter, you'll have access to over 250 projects like this, including the ones in this video. You'll also have access to my 1000x Masterclass, and my architect patrons also get to meet with me on a weekly AMA meetings. But if you can also become a free patron. I have over 50 projects for free patrons as well. Check that out. So now let's move on to the Groq Voice Assistant code. I would like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects as a patron. You will have access to all the code files so you can get inspiration and iterate quickly. Another benefit is that you'll have access to all my courses. And my most recent and most proud one, the 1000x Masterclass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the Fast API course. In my Patreon, I also have tiers in which you can connect with me one-on-one. Check those out as well. The Groq Voice Assistant is a Fast API app, full stack. And we do use Groq API. You do need a Groq API key. Let's start with the backend. So we have our files under static, our script.js, and under static folder template, we have our index.html. We are using Daisy UI and Tailwind. And essentially, we just have the main.py. That's about it. Requirements for this are fast API, Unicorn Jinja. You can read it here. So in our main.py, we are going to create a quick Pydantic model for the response format. And we define a main root with the app, and that's just going to be served the index.html, and then we're going to have a /Groq endpoint, which we're going to use to make a call to Groq. So as you've seen from the demo, this app actually can write full text, plus can modify parts of the text. So that's why we have actually two separate instructions for this when we're calling the Groq API. As you can see, the parse content, full text and selected text plus the user input is going to come in handy here. Because when you're writing, when we are writing the first prompt, then we just convert whatever the user instruction was to a text. Maybe they were asking for an email, for example. But when we want to modify a selected part of that text and we want to give the full text as a context, then give the selected text plus the user request. So let's take a look at this prompt. So if selected text, then we're going to use this prompt, but that's not the beginning, right? The beginning is actually is the first prompt, which is going to say text we're working with is full text. And if there is none, then this will be empty. Please modify the text to match the user request. And we input the user request. Only return the modified text and nothing else. But this is, I believe, but this is the perhaps the first one. I'm sorry. Please return text that matches whatever the user is asking for. Only return the text that is asked and nothing else. Here's the user input. And then we just call Llama 3.1 70 billion versatile. You can change this to whatever model. We just get the response and return it as a response. Select the text, and our front end is going to deal with all this. But if there is selected text, then we actually have a specific set of instructions for that. You will be given the full text with text and selected text from that text. I guess I could have written this better. You will also be given a user request. Your task is to modify the selected text based on the user request, considering the context of the full text. Return only the modified version of the selected text without any additional context or explanation. It is extremely important that you only return the modified version of the selected text without any additional context or explanation. Now, Llama, smaller models, it's a hit or miss with these instructions, but most of the time it works well, as you've seen in the demo. Full text for the context only, we give the full text. Selected text to modify based on user request, we give the user request, and then we ask it to modify only the selected text based on user request. Considering the context of the full text, return only the modified version of the selected text without any additional context or explanation. Yeah, I'm kind of confused on what this is. Plus, if there's a decode error, we maybe ask it again. But anyway, this works, and this main function is to just run. You can run this from the terminal, but running this app will directly run it. Here is the code to run it. This is, I think, more convenient. Otherwise, you would have run it like this. Let me display that for you. You would type in unicorn main colon app, and if you wanted reload enable, you could say dash dash reload. This will allow you to, if you make changes here, then the reload will auto reload the file. So index.html is pretty straightforward. We have some styling. Plus, we have a form control. Here we have the text area, the form control with some icons, recording indicator. That's about it. Our script, JavaScript, handles most of the heavy lifting. Check if we are using browser API for speech API, by the way. I forgot to mention. We're not using Whisper or anything. This makes things super fast. Browsers have a speech API. I think Chrome does. I'm not sure if all of them do, but this just works really well. So this is instant real-time conversion. So web speech recognition. So check this out. I'm pretty sure this works with maybe Mac too. I'm not 100%. I'm on Windows, but here's the function to start recording. We have the buttons, and we modify the attributes of those buttons. The function to stop recording. We have an event listener for the microphone button, and then an event listener for the submit button, that is to make the call to the Groq API. Okay, we pulsate the text area, by the way, while we are waiting. And this is going to make a fetch call to the /Groq endpoint. This is the endpoint that we have defined in our backend. And then once the data has come, we find the appropriate parts of it and replace the entire context with it, like here, either the entire context or just the selected parts. Function to get the selected text in the text area. Now, function to highlight the selected text in the text area. I think I made some mistakes here. This doesn't work properly, but the idea was that the selected text remains there highlighted until we receive the output. But function to remove the highlighted text in the text area. But see, we didn't really want to do this in the text area, but rather in the, I'm not sure. This doesn't really work. Maybe you can take a look. But function to auto expand the text area based on its content up to, I believe, 25 lines. So that this area can expand if there is more. So we don't want it to remain so small, but we don't want it to grow too big either. So I set it to 25. And that's about it. And an event listener to handle text selection in the output area. So this is the Groq. It is also a README. So the Groq Voice Assistant. You can improve on it. This works well, and this is available at my Patreon as well. I would like to take a moment to talk about the benefits of becoming a patron. As some of you may know, in the last year and a half, I've spent 3,000 hours, over 300 projects as a patron. You will have access to all the code files so you can get inspiration and iterate quickly. Another benefit is that you'll have access to all my courses. And my most recent and most proud one, the 1000x Masterclass, teaching what I've learned on how to code fast and efficiently. Also the Streamlit course and the Fast API course. In my Patreon, I also have tiers in which you can connect with me one-on-one. Check those out as well. Now, our final app is the guided meditation app. This uses structured outputs with OpenAI, plus it uses Needs AI TTS. So this is very cheap, very good quality TTS. You can play around with the examples. You can also get a free API key, so you don't need to sign up for this to test it out. We have a generous free version. So let's take a quick look at how this works. Essentially, the type of meditation, when you run this app, it asks you type of meditation. You can change these to your liking. Let's create a love and kindness meditation real quick. So OpenAI is going to return the instructions. We are using proper model for structured output. And then Needs AI, we're going to call Needs AI to get the transcription for each. We are also getting structured outputs to return, pause seconds, and then we are going to dynamically combine these instructions, each one of add whatever the pause seconds were created. And see, if you look at the love and kindness meditation.json, this is the first instruction with the pause seconds. If you go towards the middle, the pause seconds are being increased. Now think of someone you deeply love, visualize them clearly in your mind. I do these meditations every day, and they are very, very helpful. I would recommend you try them, but you can now try them with this app, or you can build your own. So once each transcription for each instruction has been received, let's just read one of the instructions. They say, now bring someone to with whom you we see this actually makes you imagine people you love and sometimes people you have difficulty with, and try to expand, your empathy and love towards them. Very useful. Like I said, the pause seconds are instructed to be shorter on the beginning and the end, and larger in the middle. Uh, this is the final meditation. 3 minutes and 47 seconds. Let's listen to it for a quick second.
Begin by sitting in a comfortable and relaxed position, closing your eyes gently.
Pauses are injected automatically. Let's jump to the middle.
May you be happy. May you be healthy. May you be healthy. May you be safe. May you live with ease.
And then a pause. So it's very useful. I want to expand on this, but nevertheless, this is how it works. And let's take a look at the code. We are using PyDub, and if for using PyDub, you may want to install FFmpeg, and there is some great instructions you can find installing FFmpeg. If you just search FFmpeg, one, actually Hostinger, this one, how to install FFmpeg on Linux, macOS, and Windows. This is a great, just find this one from Hostinger. If you type in how to install, I think it should be the first one, Hostinger, how to install FFmpeg. This is a great instruction. Just remember that. You would also need your free API key from Needs AI. Just grab that. We initialize our OpenAI client, and here first we define our Pydantic classes, which we're going to use for structured output. Okay, So let's take a look here real quick. We do call a special endpoint for structured outputs, and this particular model only this is the only one that currently works with structured outputs. And we do call beta and parse endpoints. Just take note of that. And once you define your pydantic schema, all you have to do is just pass the model. Pydantic schemas are called models. And the only other thing is when you are extracting this, you do have to extract it like this completion choices message dot parsed. And this is going to give you a pydantic object. And then you can, because it's a class or object, it is methods, and you can convert it to JSON by just calling a model.dump on it. There, it also has other methods like to dict, and also I believe model.dump, model dump JSON. Model dump works, it converts it to JSON. That's how we are able to save the instructions here. This is for loving kindness, and this is for Dzogchen. This is more observing the mind, resting your mind in its natural state, recognizing thoughts. This is very, very useful stuff in my mind. Anyway, so here we are defining the meditation instructions subset. So we're going to define a Dzogchen meditation, transcendental meditation, vipassana, and loving kindness separately, although they're all the same. But here we can give field descriptions. So all of these descriptions are also as given as instructions to open to the model, and you use field for that. You have to import it from Pydantic. Pydantic may seem at first confusing, but don't give up on it. It's actually easier than it looks. You just have to read up on it a little bit, have a chat about it with ChatGPT. So this meditation instructions is the our granular schema, which is passed as a list of this model to each instruction. So each meditation is going to be a list of these, okay, meditation instructions. And this is going to come in as an instruction, which is going to be a string, instructions for the meditation, and then the pause seconds, integer. The number of seconds to pause after the instruction can be from 3 to 10 seconds. You can adjust, add shorter pauses in the beginning and the end, and longer pauses in the middle. And then we pass that as into a list. So for meditation, instruction is going to be a list of these. And for Dzogchen, the instructions are pointing out method. Read up on this, very interesting. Transcendental, Vipassana, and Metta, loving and kindness method. It's also called Metta. And then we ask the user which one they want to choose with a list. And here if it's, for example, Dzogchen, then we select that model. If it's transcendental, we select that model. Then we have a system message for for the model generate guided meditation for this meditation type, and now we create a user message that says, "I would like to perform this type of meditation. Please provide instructions and pause durations." And we pass that particular model as a response format. Then we get the response as meditation instructions, convert it to JSON, and save it to a JSON file like we have done. And then for audio generation, we get our needs API key from our environment variables. This is the way to make a call. We still, with needs, you have to do requests. And essentially, we just write the responses, right? Generate audio for each instructions and combine with pauses. We create an empty audio segment, enumerate all over instructions, generate the audio for each. We add it to the combined audio. We add the pause duration. We use the audio segment that silence for that to create silence, and we combine it with that silence and export final audio very easy, and clean up the temporary files, those temporary instruction audio, and then we print that the meditation has been generated. So this is it. I hope you enjoy this. If you are enjoying my videos, you can actually find all my videos at my website, echohive.live. And remember, we looked at the O1 manager. I have actually built stuff like this with Groq, which actually worked better, but I put perhaps more care into it. It's good that you may want to review them. So Coder team, remember the 6-agent Coder team? Hey everyone. Let me do that again. This one was using a 6 agent coder team using Gemini, DeepSeek Coder, even Sonnet. If you may want to watch that. There was also agentic game dev, which uses A plus agents. All of these were creating the individual files separately. So it's interesting to take a look. And I would highly recommend you work with Cursor, of course. That's all I do. I mean, it's just a no-brainer in my mind. And I created a 1000x masterclass for that. Currently, there's 20 chapters. You can watch the first chapter, the Cursor Deep Dive, for free. This requires you to become a patron, but I think you'll really enjoy it. It has 20 chapters, such as how to build full stack apps with Fast API, Next.js, how to build market research, multimodal RAG. There's 20 chapters here, and the last one is how to build the O1 coding team project manager. It's 50 minutes long. There's 10 hours of video here, content. You can preview each video for 2 minutes. So take a look at that. And I also meet with my patrons every week on every Sunday for AMA. So you can talk to me directly there. But if you want to get in touch with me on a one-on-one basis, I do provide consulting at the higher tiers at my Patreon. Take a look at that as well. Okay, now let's take a look at the preview of how to build the O1 Coding Team Manager. This will be a few minutes preview of the full episode from my full chapter from my 1000x masterclass. If you like this and want to watch the full course, you can join my Patreon and watch it from my 1000x masterclass. Thank you. Hey everyone. Okay, let's build a O1 coding team manager. So we are going to get O1 to manage a coding team of Sonnet coders. So here I am at OpenAI docs. Copy this reasoning O1 sample code. Let's come here and let's just type in manager.py. Let's actually say AI manager. .py. So this should be pretty straightforward. We're going to start with Control K or Command K. We are using Claude 3.5 Sonnet with Cursor. Let's give this code as example, and then let's say we want this model to be let's say project manager. Oh, might be a project manager for a coder team of multiple AI bots, which will be building multi-file projects. The manager AI will need to provide all the information necessary for each file to be built, for each, let's say, code file to be written independently of other files. Okay, let's say that. Uh, let's give additional information. Each coder agent will be writing a single file and will have no information about what the other, let's say, agents are writing. Therefore, the manager AI needs to explain the file to the file which each agent needs to write in a complete and self-sufficient way, so that if these instructions were given to a human developer, they will be able to write this single file, which belongs to a multi-file project, just by looking at this instructions for this file alone, and the file will work perfectly in combination with the other files. Okay, this is good. Instruct the manager AI to return a plan, return a detailed plan about the multi-file project in plan tags. Let's say that tags, and instruct the manager to return each file with all the necessary information in between file folder slash file name. Let's say file name, folder slash file name tags. Yeah. Return a folder name where necessary. The manager should return a folder name where necessary, or just the file name if the file is in the root folder. Okay, let's just do this. We will take in user input, and manager will plan the project based on the user input. So we're going to do this. Let's just let it write it. I wrote so much. Maybe we could have done it, but okay, right. Yeah, it didn't. Okay, it wrote, let's see, project manager. We got a call, create a project based on user input. All that is good. It's using a system message, which we cannot use O1. We'll fix that. It's at least working to parse the response. So that's good. Project plan, file instructions. That's good. Seems this is good, but we need to add additional instructions. Do not use system message with the manager. Also, improve the instructions and describe to the model how it should return the plan and plan and each file. Let's see what it does. I just wrote a follow-up. Okay, so this is much better. For each file, provide complete self-sufficient instructions that will allow a human developer to write the file independently without knowledge of other files in the project. Imports the functions or classes. This is pretty good. And we're no longer using system message. What else? Okay, let's say save the plan and each file's description to a txt file under